Hello and welcome back to another devlog, guys. So today we're working on our player. We are going to be building from the ground up the player. We're changing it from the original CharacterBody 2D to our RigidBody 2D. As you can see here, I have already done this, but I'm just going to go through the changes I made. And if you guys want to do it as well, I'll walk through the changes you can make as well. Also going to explain what a RigidBody 2D is and what I previously had as well, explaining the differences. Also gonna go through the debugging process I had to do because, you know, there is a lot of debugging. But yeah, anyways, let's get into it. The first thing you guys need to know is what is a RigidBody 2D. So basically a RigidBody 2D is something that can be controlled or a physical object that kind of has mass, inertia, rotation, etc. So usual cases are you can have things that aren't really controlled by the user inputs like crates or boxes, but you also want them to be physical objects that the player can interact with. These will have like realistic physical properties as well. As you can see on the properties panel here, you can set any of them to whatever you desire. You can change the friction, you can change the bounciness, you can change mass, inertia, etc. So the way we control our player with code is using the integrate forces function. Basically, the two main things you need to know is apply central force gives a forward force or consistent force in a direction of your choosing. And then also apply torque is going to be our left and right. So the torque basically means a rotational force. It's similar to just pushing it forwards, but in terms of rotation. There's also another few functions that you can use, namely apply impulse and also apply torque impulse. So these are like apply central force and apply torque, except instead of a constant force, it's only one time. So it's a small hit. This isn't really going to be good for our player because we want when the user is holding the W key down for it to consistently go forward instead of just jump forward a small bit one time. So after that, we are also going to explain what a CharacterBody 2D is. So a CharacterBody 2D is similar to our RigidBody 2D, except it doesn't have very good physical realism. Instead, it kind of supports more user inputs, and it's good if you want to create a game like Pokemon where the player has simple movement controls. So this is the main difference between RigidBody and CharacterBody. This is the physics that makes the CharacterBody move, basically. We're changing velocity and we're just changing it directly. Don't worry about the max follow length either. This is just for our AI player on the menus. But yeah, we're changing velocity instead of basically applying a force, which is what you would do normally in real life. When you're actually pushing the trolley in real life, you're pushing a force forwards from the back of the trolley. And when you're turning the trolley in real life, you're applying a torque around the center of mass of that trolley. So the end result is that you get a really more realistic version of movement when you use the RigidBody rather than the CharacterBody. If we just run the project, we can see that it's super slidey. When we turn, it's kind of got a little bit of lag behind it. It's not direct, and as you can see, bumping off the things looks really like realistic as well. We didn't have that before. It was just sliding along it. However, as you can see just there are some visual bugs. Namely, if you get too close or you bump into it too hard, it kind of spins out and doesn't really, I guess, behave very realistically as if you were to do it in real life. If you banged a trolley against the wall in real life, it wouldn't spin out uncontrollably and snap all of your ribs off or whatever. Occasionally, when we do restart the game, we can't move. I'm pressing WASD here and it's not moving. I have no idea why. If you guys want to let me know in the comments why this is happening, feel free to. If we just take another look at what else we're doing in the code, the player code, we are lerping the facing direction. So lerp is short for linear interpolation, if you don't know already. It just basically means it smooths out. So the first argument is what we want is as the initial amount, and the second argument is the final amount. So the initial amount obviously is our facing direction, and we want it to go towards our sine and cos of our rotation. So the rotation is an angle from the horizontal, what our player is facing towards. And the cos and sine basically give a vector 2 direction towards it. So if we were facing fully right, it would be 1, 0. If we were fully up, it would be 0, 1. So you kind of get what it means. The facing direction is going to be the vector 2 direction where it's facing. We're then using the facing direction to calculate the forces. The force is going to be clamped at a maximum speed. That's where our max forward speed is getting used. And then also similarly with the backwards one, it's going to be clamped at our max backward speed. Clamp, as the name suggests, just limits the length of the velocity, so it just means that we can't speed up infinitely and basically break the game and cause all sorts of problems. Also, when we choose upgrades, what's upgrading is actually this max forward speed value. So when you purchase upgrades in the menu, these are going to be maxed up, so you'll be able to travel faster in the long run. However, acceleration I don't have an upgrade for yet, so acceleration is just a constant 500 that I've set it to. Obviously, if we're traveling backwards, we're going to have to times it by -1 just so we move backwards. And also you'll notice that I've divided it by 2 because I want the backwards speed to be quite a lot less than the forward speed. Basically, the rotation acceleration as well is going to be our upgrading thing. So when you upgrade the rotation, when you purchase the rotation upgrade, this value is going to be upgraded. Still have a little bit more debugging and looking into to go because of the bugs that happened with the inputs and also the bugs that were happening with the on collision with the collision shapes. So I've just drawn up something really quickly. This dot here represents the position of the wheel, the green dot, and then the blue line here is representing what axis of rotation we want the wheel to be at. So we want it facing either this way or this way in terms of what direction the torque is being applied in or what direction the body is rotating in. This line here just represents the direct line from the center of the body to the wheel itself, and it's going to be used to calculate what direction we should use it. So if we take the wheel position and we find the tangent of it, so we're using atan2, which takes in a x and y coordinate, and it will basically get the angle of the tangent. So the tangent in this case being this line here, given the x and y coordinate. So it's really useful for exactly what we need to do. So we're given it the y position, we're given the x position. It's going to calculate the angle of the tangent. That's all good. But what happens if we switch directions? Because right now, if we just use this, it's just going to stay in the same direction no matter what. That's where this comes in. So first we just initialize it to nothing. We check if the angular velocity is greater than 0, which means it's moving right. If it's moving right, we set it to 0, so basically in here it's subtracting nothing, it's just normal. If it's going left, however, we're going to equal x to 1. So then at the end it will be subtracting just pi. If we turn left, it just moves around like that, and if we turn right, it swaps around. So it's flipping to 180 degrees, which is pi in radians. So that works exactly what we need. We can see that's how trolleys basically move. It's going left and right, and then also when we're moving forwards and backwards, it's also the wheels are also updating in respect to that. And if we're going sideways, the wheels are basically sideways. It's just following basically our direction of motion. So that was all for today. If you guys enjoyed, make sure to drop a like. If you guys want to see more stuff like this, let me know in the comments or let me know what I should add next. Also, if you really don't want to miss another episode, just make sure to subscribe. Hope you guys enjoyed. I'll see you in the next one. Bye.